Hi everyone, welcome to the fifth and final video of getting started with the Our Sci Reflectometer. There will be more tutorials, but this is the final video to walk you through this getting started one pager that comes with your kit. So in the last video, we finished our calibration, right? And just as a note, one thing I forgot to list, once you calibrate, make sure you screw this back in place. You don't want to lose this piece. As I said, it would require us re-intaking the device and calibrating to a new one. So screw it back in place. And now that I've just calibrated my device, I'm ready to actually run my reflectometer and get a nutrient density estimate. So this is the final step in our getting started. And of course, if you're running a different survey, it just means you're ready to start running that survey, right? Like you've completed calibrating your device and you can run some accurate measurements. So I'm going to once again start my nutrient density estimate survey in bionutrient.surveystack.io. If you're an RSci user, use surveystack.io as is shown in this one pager. I do not need to calibrate my instrument. I just calibrated it, so I'm going to click next. And it brings us to the same page that would pop up at the end of a calibration. So I'm ready to run my estimates, and I can choose my crop type. We have quite a few crop types that we have models prepared for. I'm going to run mine on kale. So I'm going to choose kale. And I'm going to choose the color. So my kale is green. I have a bag of kale here. Oh, and I didn't select it. There we go. My kale is green, and I'll click next. And this page is just an explanation of what you should expect to do in this survey. So to start, it tells you that we're asking you to run 3 scans. That's so we can get 3 data points, average them, and feed that through our model for what should be a hopefully more accurate prediction than if we just had 1 data point. Additionally, we ask that between those scans, you remove your sample and reinsert it. That's to make sure that you actually are getting 3 separate data points instead of 3 scans of the exact same data point. So that's this block. And then below that, you'll get instructions for what you're scanning. So in this case, I'm scanning a leafy green kale. If you chose beets, you would get instructions for your round object, and you would be told how to use a round object guide. If you were doing grains, you would be using your glass petri dish, and you would be running a grain sample. So I'm using my leafy greens. I'm being told that I should choose 3 different leaves, 3 different sections to sample, and that I should scan the darker side. So I've just ripped off little pieces, 3 pieces of the larger leaves so that they're a little bit easier to manage, because I want these samples to lie flat on the device surface. So I clicked next. I'm on scan 1. Again, this is the portion that matters. We have our LEDs in the middle and detectors on either side to read the results. So I am going to clamp down my sample, but I want to make sure that my kale is as flat as possible against that light guide. So you can see this clamp is lying pretty flat, could be flatter. Let's try to wiggle it around a bit and make sure that it's really, it should cover the entire light guide. It should lay pretty flat. That's pretty good. I'm going to set it down on a stable surface as we did with the cuvette standard scans and calibration. And I'm going to run my scan. And my device, since I calibrated actually, because it's been a few minutes, has powered off. So just as a reminder, this button, I'm going to power it on, and you can see that blue LED. Once that's back on, now I can click connect to device. My device ID is 249. So it's connected to 249. Your device ID is something different. Now it's connected. I can run my measurement, and I'll see the LEDs shining up through that kale leaf. And now I have my results. I'll click done, and I get my success statement. So I know that was good. Next, I'm going to entirely remove this kale leaf, set it aside, and get another piece from a different leaf in my bunch. If you only have 1 leaf, just get 3 different portions. Here's another leaf. And again, I'm gonna try to get it as flat as possible. And this one is a little bit easier for me to set up. Actually, it's pretty flat. You can actually see the magnets are connecting, which is what you want. And again, now that this is set up, I'm gonna set it on my table. I'm gonna run scan and start measuring. And I can see the LEDs flashing. This is my second data point again, so I have one more. So I'll start prepping my third and final leaf. And again, the darker green side down. Now that this is done, click done. I have another success, no errors. Again, you can see the spectral data below, but that success is really all you need. And then I'll click next, and I'll do my third and final scan with this last leaf. And again, it's key. You want to make sure this whole light guide, everything in there, that clear space is covered. And you want to make sure that your clamp lies as flat as possible to really press it in place. And I can click run scan, start measurement. I can see the LEDs flashing again. And you really, every sample you run your 3 scans, you'll get quick at it. You can click done. I see my success. And now it's time to get results, right? So we're going to feed it through the model that we have made from hundreds of samples that we tested in our labs. And we're going to get a result that is basically color coded on a spectrum of values. So I'm running results. My kale is average. It's in about the 61st percentile. With an 80% confidence interval, you can see it's actually quite a broad range. It could be a lot lower. It could also be significantly higher, but they're saying that they think based on the model, based on the scans that I did, it should be in about the 61st percentile. And that is for polyphenols. So as I said, we have about 10 different crops right now. That number is growing that have these models that you can test. Some of them have polyphenols, some have antioxidants, and some have both, some have other things, but you'll get a general sense of nutrient density for whatever model is made for that. And you can see, I mean, once you see your results, you know it was successful because you have results and you can click next. And this is just a summary of my survey. I didn't calibrate my instrument this time, and that's okay because it was just calibrated before this video. I chose my crop type, the color, I ran my 3 scans, and I applied my model. So now I can click submit and confirm submission. Okay. And then it spits me back out at the beginning of this survey, so I could run it again if I want to. Well, hopefully this was helpful. That's generally the process that you'll go through for both the nutrient density estimate and the soil carbon estimate once we get that up. Of course, we can help you create your own survey if you're interested. We also have, as you can see down here, we have our weekly calls if you need help. It can be from really anything, setting up your phone, learning how to calibrate correctly if you're having trouble, just sharing results if you want to come. It's a community call, so it can be tech support. It can also just be coming and talking about what you're finding. We're talking about new use cases. We also have a forum if you're interested in posting there, and we have a support email if you're in need of help and can't make those meetings. Lastly, our online tutorials are at this bit.ly link, or you can use your phone camera and you can just hover over this QR code, also found on your device, and that will pop up with a link to the same online tutorials. Great. Well, again, I hope this was helpful. Thank you for watching, and we'll be making more of these for additional use cases beyond just getting started.